Good morning. I want to finish up a couple of more details with you before we take the test on Module 1. Review sheet number 4 talked about solving absolute value equations, and we talked about a couple of special ones while we were doing the material in class, but none of the review problems were like this, so I just wanted to make sure you knew how to do them. Let's take a look at this equation first. Let's go the absolute value of t plus 15 equals 2t plus 25. Now, when we're solving absolute value equations, remember that the first thing you have to do is make sure the absolute value is by itself, that there's nothing over there with it. Well, there's nothing over here with this one, so we're ready to solve it. The other thing you need to remember is that absolute value means distance from 0. And the distance can be to the left, so it goes to a negative boundary, or distance to the right, so it goes to a positive boundary. So we're going to make one equation for each one of those. So this is our distance, this 2t plus 25. Yes, I know it's an expression, but it still represents the distance. So when we go to the left and go to our negative boundary, we have to take the negative of both of those, which means you just change the sign. So I change the sign of the first term, change the sign of the second term, and set it equal to the absolute value expression. Now, normally we write our second equation right next to the first one, but we don't have any room here, so we'll do them one at a time. So we're just going to solve this for t. So I'm going to subtract t. I get negative 3t minus 25 equals 15. Then we'll add the 25. And you get negative 3t equals 40. And then divide by negative 3. So you get t equals negative 40 over 3. Now you should always check your answers, especially if there's a bunch of stuff in your equation. So we're going to take negative 40 over 3, and we're going to put it in place of the t in both cases. Well, this first one would be absolute value of negative 40 over 3 plus 15 equals 2 times negative 40 over 3 plus 25. Running out of room there. Well, the easiest way to add these two together, if you don't have a calculator, is you just make this number so it has a 3 on the bottom. So when I do that, I just times the 15 by 3, and I get 45 over 3. So now I can add them. Negative 40 plus 45 is 5 over 3, and the absolute value of 5 over 3 is 5 over 3, equals 2 times negative 40 over 3 is negative 80 over 3, and then you add 25 to it. Well, again, remember, when you're adding something that has a fraction, it's easier to have them with the same denominator. So I just multiply 75 times 3, and I get, or 25 times 3, and I get 75 over 3. Well, negative 80 over 3 plus 75 over 3 is negative 5 over 3. So I had 5 over 3 over here. I have negative 5 over 3 over here. They are not the same. So since they are not the same, I cannot use that answer. That's what we call an extraneous root. You didn't do anything wrong in the problem. It's just that because of that absolute value symbol, it sometimes makes some of those answers not work. So you have to throw it out. So that first answer gets thrown out. And now we're going to do the second equation. Remember, the first equation is where we went with the negative of everything. We went with the negative of all of this. Now we're going to go with the positive. So I'm going to go t plus 15, and I'm going to use the positive of that. And now we're going to solve it. So subtract t, we're doing the same steps as we did before. So I get 15 equals t plus 25. And then subtract 25. So I get negative 10 equals t. Now again, we're going to check it. So we're going to put the negative 10 in there. So I have negative 10 plus 15. And then I'm going to put the negative 10 right there also. Well, negative 10 plus 15 is 5. The absolute value of 5 is 5. Over here, 2 times negative 10 is negative 20 plus 25. Well, negative 20 plus 25 is 5. So these are both the same, so that answer works. So that's the only answer to the problem. But the point I wanted to remind you of was that if you have an expression over there, more than one term, when you do the negative boundary, you change both of those signs. And when you do the positive boundary, you leave both of the signs the same, even if the signs were negative. For example, if this said negative 2t, when you do the negative of it for your first equation, you change that sign, so it becomes positive. You change that sign, it becomes negative. And then when you do the positive boundary, you leave the signs the same. This stays a negative, that stays a positive. So that's the first one I wanted to remind you of. Let's take a look at this one. It's another example of kind of a weird one. Let's take a look at the problem absolute value of negative 5x minus 8 equals 5x minus 33. Okay, remember, the absolute value has to be by itself, so this negative 8 can't be there. So we're going to add 8 to both sides. So you're going to get the absolute value of negative 5x equals 5x minus 25. So we're in the same situation as we just were. We have an expression over here. So we're going to do the same thing we did before, but this problem has another wrinkle with it also. Well, here we go for the first one. We're going to take the opposite of both of these for our negative boundary. So the opposite of that is negative 5x. The opposite of that is plus 25. And we set it equal to the absolute value. And again, we normally would write our second equation over there, but we don't have any room, so we'll do it one at a time. Now we have an x on both sides, so we're going to get rid of one of them. So let's add this 5x. And right now, some of you are already figuring out where this is going to be different. This cancels, and you're left with 25 equals, well, that cancels also. Well, 25 doesn't equal 0. There's no x left in the problem. But since 25 doesn't equal 0, this half of the problem doesn't have any answers. Normally we get one answer for each equation, but in this case we don't get an answer for the first equation because the variable disappears. So we can just throw that part out, and now we'll do the second equation. The second equation, whoops, I shouldn't have erased that all. Okay. Our second equation would be when we use the positive of that, which means we leave the signs the same. So I still have my absolute value and the positive of this. So go ahead and solve it. Minus 5x. Now be careful here. Those are the same signs, so you add them together. And then divide by negative 10. A negative divided by negative is a positive. 25 over 10 reduces to 5 over 2. Now we go ahead and check it. So in order to make it easier to see, let's just erase this and we'll put it in right underneath the problem. So I have negative 5 times 5 over 2 minus 8 equals 5 times 5 over 2 minus 33. Sorry about that. Okay, remember when you multiply, you just multiply straight across. So negative 5 times 5 is negative 25 over 2. Well, the absolute value of negative 25 over 2 is 25 over 2 minus 8. Five times 5 over 2 is 25 over 2 minus 33. So this is where we are right now. Now, again, some of you are going to figure this out right away. But in case you don't, we're just going to simplify both sides. Remember what I told you a few minutes ago? Was that if you're combining two terms, one of them is a fraction, just take this number here and multiply it by that. So 2 times 8 is 16. And now it has a 2 on the bottom. Well, 25 minus 16 is 9. So that's 9 over 2. Now do the same thing over here. We have a fraction. So multiply 2 times 33, and you get 66 over 2. Well, 25, because they both have a 2 on the bottom, you just subtract the top. 25 minus 66 is negative 41 over 2. These are not equal to each other. That means that answer won't work either. So you got no answer from the first equation because you ended up with 25 equals 0. If you look back at your notes, we ended up with 25 equals 0 on the first half, which wasn't true, so there was no answer there. This one, we actually got an answer. We got the answer of 5 over 2, but when we plugged it in, it didn't work either. That means nothing works in the problem. So there's no answer at all. So you have to be careful. You can do the algebra correctly, but you could end up with answers that don't work in your original equation. So you need to check those. Extraneous roots don't happen very often, but they happen often enough that you want to make sure you check them. Okay, a couple of other pieces of information. You are going to have some short answer and essay questions on the test. And those just have to do with content information, if you will, like what's the difference between this and this. So I want to make sure that you look at those. One thing would be you need to know how to evaluate an expression. Well, remember, evaluating means finding the value of. So if we're going to evaluate an expression, I use another color here for the answers. How do you evaluate an expression? you plug in the numbers. Whatever numbers you have, you plug them in, and then you just simplify the problem. Okay, that's a fairly simple, short answer question. Another question, because we end up with them sometimes, the difference between terminating and repeating decimals. I'm using a lot of abbreviations, but we're running out of space. So what's the difference between a terminating decimal and a repeating decimal? A terminating decimal ends. In other words, it starts and it ends. So it could be something like 0.25 or 0.1876. Doesn't matter how long it is, as long as it ends. Now, sometimes when you put a decimal in your calculator, it fills up the whole screen. So it's a little hard to tell whether it maybe would end farther on down the road or if it goes forever. A safe assumption is that if it fills up the whole screen, it probably does not end. A repeating decimal does just that. It repeats. It could repeat one number or it could repeat 5 numbers. Like a repeating decimal, this is a common one. The little bar over the top is repeating, 0.3 repeating. Or it could be like this, 0.45, 2 numbers. Or it could be 0.28763. As long as all of the numbers repeat, then it's called a repeating decimal. So that's the difference between those two. Another short answer that you might get is, what's the difference between solving an inequality versus an equation? In other words, a problem that has a less than or greater than sign in it, and a problem that just has an equals in. Well, the short version of that answer is that when you're solving an inequality, we have to remember that if you divide or multiply one or the other, both sides by a negative, the inequality switches, flips. In other words, if you multiply both sides by a negative or you divide both sides by a negative, it switches the less than to greater than or the greater than to less than. It flips. Doesn't do anything if you're adding or subtracting. So that's the big difference when you're solving inequalities versus solving equations. Another difference short answer question that you may run across is, what's the difference between an intersection and a union? An intersection, remember, intersections are and problems. And when you're graphing, you're shading the area in between the two dots. Normally, 99% of the time, you're going to shade in between the two dots. So intersection is you're looking for the solutions. Solutions that work in both inequalities. That's the key. The answer has to work in both the first sentence and the second sentence. The first half of the problem and the second half of the problem. If it only works in the first half of the problem, then it's not an answer to the problem. A union, these solutions work in one or the other. In other words, it works in the first equation or the second one. It can work in both of them, and that's okay, but it doesn't have to. It just has to work in one sentence. So if you happen to have a multiple choice question and it wants to know why something is an answer to a union problem, if one of the answers says, because, say the answer is -4, this is a solution to the union because it works in the first sentence. Or you might get another choice that says, -4 is a solution because it works in both sentences. You want to give the answer that it works in the first sentence because a union doesn't have to work in both sentences. And even if it does work in both sentences, that's not why it's a solution. It's a solution because it worked in one of them. It's kind of a weird situation, but you want to make sure that you don't imply in your answer that the union has to work in both, because it doesn't. Another difference question that you might run across is the difference between pairs of parallel lines or perpendicular lines. Well, here, the only thing that you're being asked to remember is that parallel lines have the same slope. So if you have a pair of parallel lines, you have two parallel lines, whatever the slope is of the first one is also the slope of the second one. Perpendicular lines have opposite reciprocal slopes. Opposite meaning if one is positive, the other is negative. If one is negative, the other one's positive. And then reciprocal means that they flip upside down. So if one slope is 2/3, the other one is the opposite, so it's a negative, and it flips that upside down. If one slope is 4, or let's make it -4. If one slope is -4, the other slope is positive, and then you have to flip this upside down. Well, remember there's a 1 under there. So when you flip it upside down, it becomes 1/4. So that's what you need to remember when you're talking about parallel lines and perpendicular lines. And you'll also remember that, use that when you're writing equations of parallel lines and perpendicular lines. Let me see. Oh, remember, you will be asked to give the steps for simplifying. You have an expression and you're going to simplify it like this. The thing to remember for steps for simplifying is, please excuse my dear Aunt Sally. That's the key. You do the parentheses first, then you do exponents, then you do multiplication or division from left to right, and then you do addition or subtraction from left to right. So in this case here, 8 plus 9 is 17, and I should not have used really big numbers. So let's make this a little simpler. Let's make it 3 minus 2, and then go plus, we'll go 8 over 4. Okay, 3 minus 2 is 1, so it looks like this. We'll just do one step at a time. Now the E stands for exponents. 1 squared is 1. Then we do multiplication or division. Well, here's the multiplication or division piece. It's way at the end there, so we do that first. 8 divided by 4 is 2. And then we do addition and subtraction, and we go from left to right. So we go 1 minus 4 is negative 3, plus 2 is negative 1. But there's the key to that answer. You need to be able to explain what that expression means. And then probably the last thing, if you're solving something, you're trying to get a variable by itself, remember we still do this, but we do it backwards. You get rid of adding and subtracting numbers first. So if I have something simple like 2x plus 3 equals 15, I get rid of adding and subtracting numbers first. Then you get rid of multiplying and dividing numbers. The other thing, when you're solving, as far as your steps are concerned, the first thing we do is you distribute if you have parentheses. Second thing you do is combine like terms. If you have terms on the same side of the equal sign that can be put together, put them together. Make the problem shorter. So when you finish these two steps, this is the longest version of your problem. You might have a letter term, and then you might have a number, and it would be the same thing on both sides. That's the longest your problem will be once you finish that. So it might be something like this, 3x plus 2 equals 8x minus 7. That's as long as you'll have. So then once you've gotten to that point, step number 3 is if you have two x terms, if there are two letters, if there are two letters like there are here, then remove the smaller. And when you remove a term, you either add it or subtract it. Then you are at PEMDAS backwards. You're at where we were talking about before, where you would get rid of added or subtracted numbers first and then multiplied and divided numbers. Okay? So that's what you need to remember as far as solving equations are concerned. I think the only other piece of information I want to make sure that you know of is the test is scheduled for Wednesday. There are 34 questions, I believe, on the test. You'll have a limited amount of time to take the test, at least at this time. That's the decision I've made. I might change that. But if you have anything from any of the review papers, there are 5 review papers. If you have any questions, then I expect you to either contact me during the Zoom time, or I expect you to come in and see me after school on Tuesday so we can go over everything. We may move the test till Thursday, but don't count on it. Count on it being on Wednesday so that you've planned everything accordingly. If we move it back, then you're just ahead of the game. But make sure that you're ready. Make sure you get in touch with me if you have any questions, if you don't know what you're doing. Because we may not have another test this marking period, this grade's going to be pretty valuable. So make sure that you're ready for it. You do not have to do the review sheets, like I've said several times before, but it's silly not to. You don't have to do all the problems, but you need to do enough of them so that you are familiar with the kind of question that I might be asking you on the test. So get in touch if you have any questions. Thanks, guys.